Okay, let's look at a scenario with a triangle where we know all three side lengths and we have to solve this triangle. So keep in mind that solving a triangle, and this is not going to be drawn to scale here, okay? But keep in mind that solving a triangle means finding all of its sides and all of its angles, right? So we can label this any way we want. They've given us side lengths. We know they're side lengths because they're lowercase letters. So let's make this side A. But if this is side A, angle A has to be across from it. If we want to make this side B, angle B has to be across from that. And we'll make this side C, angle C across from that. So when you're solving a triangle, like we said, we want to know these three angles. And it's not a right triangle because this is not a Pythagorean triple, right? So and it's not a multiple of a Pythagorean triple, right? So this, I mean, if you break it down, this is 5, 6, 8, right? Each one of these is divisible by 2, and 5, 6, and 8 are not the sides of a right triangle. So this is an oblique triangle. Solving for the angles is going to take either the law of sines or cosines. And since we have a side relationship, we know we're going to use the law of cosines, okay? And we've talked about how the law of cosines is really any combination of these sides where you isolate one side and the angle across from it is inside this cosine function over here. The other two sides end up in this combination on this side. Now, if we fill in what we know here, we've got 10 squared, 10 squared equals 12 squared plus 16 squared. You can hear Evelyn in the background. She's in school right now in a first grade classroom where they all just shout at each other. And so what we're solving for first is this angle, right? That's the only unknown value in this problem. So when you look at what we know, there is some calculations that we can do, but really we're having to solve for this A, which means having to isolate this package first. Okay, so let's calculate what we know here. We're going to have 100 equals 144 plus 256 minus, now this is, right, one big product. We can multiply this in any order that we want. Ooh, can I do this in my head? Let's see, 48, is that 208? So 416, that's my guess. But I've got Desmos queued up here. So 2 times 12. Ooh, way off. How did I get that? 384. Okay, that's why we check, right? So this is 384 cosine A. So we're trying to, again, so if we're solving for A, we have to isolate the trig package first, which means we're going to have to isolate this product. So we're going to move these values over to the other side. So when we subtract 144 and we subtract 256 over to the other side, we're going to have negative 300 over here, which is a good sign because this negative is still attached to this 384 cosine A, right? So we move these constants, this negative is still here. To get at this cosine, we have to undo this multiplication with negative 384. So we divide by negative 384. And that's what Desmos is for, right? Now we definitely need that. What's 300 divided by 384? And I'm going to see if I can get that as a fraction, right? And we've got that toggle button over here. So we get 25 over 32. And I'm going to, there we go. I'm going to keep that 25 over 32, right? We had to divide by a negative. Negative over a negative is positive, and this is equal to the cosine of A. And to continue with that, we have to take the inverse cosine. So we're going to inverse cosine both sides. So we have the inverse cosine of 25 over 32. The reason I like to leave that as a fraction is because I know that's the exact value. It's not a truncated decimal. It's not a rounded decimal. Okay. Come back to Desmos or whatever calculator you're using now. We're dealing with triangles. Angles and triangles are most typically measured in degrees, not radians. So you want to come over here to the wrench and convert your mode in your calculator to degree mode. All right, where did, get rid of that, here we go. So we have, under the functions tab, we have all of our trigonometric functions here. Oops, we're taking the inverse cosine of 25 over 32. We'll call that 38.625, right? So if we want to round to the thousandths place, we're going to look here and see that the 8 moves this to 5. So 38.625 for our answer here. Degrees. So that's the measure of angle A. Keep in mind that we don't put the M and the angle symbol in front of these angles like so. So now when you come back up here, we actually know this angle's approximately 38.625 degrees. Okay. Now you can go through this law of cosines again and do the exact same problem, okay, for angle B. The only difference is when we write our equation, we'd have to swap all of the A's with B's, right? So if you wanted to find this angle right now, okay, you could say B squared is equal to A squared plus C squared minus 2AC cosine B, and go through all of these calculations exactly how we did them here to solve for angle B. An alternative approach is, now that we know there's only one triangle here that this can create, and I have a pair of opposite side and angle, now I can go to the law of sines at this point. Okay, so I could say 10 over the sine of 38.625 is equal to 12 over the sine of B. It all depends on your preference for how you want to set this problem up, okay, once you get that first angle, right? Now, there is such a thing as the ambiguous case, which we'll talk about in some other videos in a different lesson. So if you want to be absolutely positive that you're getting the correct answers, even though this problem takes a little bit more work than the law of sines, using the law of cosines to get that second angle is always going to be your safest bet, okay?